All right, everyone. So welcome back. Today, in this video, we're going to talk about a new type of problem. So this type of problem is going to be asking the same questions we talked about all along. So increasing and decreasing, local max and mins, concavity, points of inflection. But the interesting thing is here, instead of me giving you an equation of f or even a graph of f, I'm going to give you a graph of f prime. This is not f. This is a graph of f prime. Okay, so what that means is that the y value is your f prime, meaning the height of the graph is the f prime value. So if we just look at a point, so for example, if we took a look at this point at 3, 2, what that means is that f prime of 3 is equal to 2. So the height of the graph is the slope of f. Okay, so this problem we're going to ask some of the usual suspects. So let's just start with these. And again, what I want to remind you guys on these problems is to start with the definitions. We want to practice writing these up cleanly and using the proper mathematical definitions. So we say, where is it increasing or decreasing? Okay, so let's go to our definition. F increases when my f prime is positive. Okay, so whenever we're above the axis, because my y value is f prime, whenever we're above the x-axis, my f prime is positive. Anywhere below the axis, my f prime is negative. So as to where we're increasing when f prime is greater than 0. So in my picture, I see that happens on the interval from -6 to -2. And then we're still above the axis. My f is still increasing from 2 to 5. So I think of these problems as like going back to our definition. So f prime is bigger than 0 here. How do I see f prime? Well, again, f prime is just the height of this graph. This is a graph of f prime. Anywhere we're above the axis, we have a positive f prime. So f decreases, in this case, when my f prime is less than 0. So where am I under the axis? And the only time that happens is from -2 to 2. Okay, so that's how we approach that problem. So now let's talk about how we find a local max or a local min. Okay, now we could use a second derivative test, but for me it's easier to do these when the first derivative goes positive to negative or negative to positive. Okay, so that's going to happen. Let's see, my first derivative is positive then negative. I see a switch right there, and I see another switch right there. So let's see what's going on at each of those points. So if we look at x equals -2, my f prime switches from a positive value above the graph, positive to a negative. F prime switches from positive to negative. So if my slope is positive and then negative, it is a local maximum. Now, a chump would say there's a local max of 3, but again, this is a graph of f prime, so we have to read it differently. That's why I think it's really helpful to think about this definition, like where do we switch from positive to negative, and try and think about it from that perspective. Okay, and then if we look at x equals positive 2, so right at that point right there, my f prime switches from a negative to a positive. Okay, so f prime switches from a negative to a positive. So I have a negative slope and then a positive slope. So f has a local minimum there. Notice how I'm being clear. I'm not saying the graph switches from positive to negative. I'm saying f prime switches from positive to negative. Just make sure you're clear about that. So again, go back to these definitions, right? What does it mean to have a local max? What does it mean to have a local min? And I think that's going to help you read the graph and do that. Okay, now I also asked you about concavity and then points of inflection. So let's go with those definitions as well. Okay, so you are concave up when your f double prime is greater than 0. So how do we see f double prime in this graph? Well, that's, I think, something worth thinking about. So f double prime equals the slope of f prime. So it is the slope of this graph. So where does the slope of this graph? Positive. So I'm going to try and highlight that here. So the slope of this graph, we have a positive slope of f prime on there and then also on there. So that happens, it looks like, on the interval from 0 to 3. So this is the key. This f double prime being the slope of f prime, write this down every time. That's going to remind you what to do, and that's going to earn you credit on the AP test. So you're concave up when f double prime is positive. So when the slope of f prime is positive, so that happens on the interval from 0 to 3. You are concave down when your f double prime is negative. So that's when the slope of my f prime is negative. So where do we see that? Let's switch to a different color of highlight here. Yeah, that'll work. So where do we have a negative slope of f prime? So f prime is a negative slope here. Because we know f prime is a derivative of f prime. F double prime is a derivative of f prime. So we're looking at the slope of f prime. This was a terrible color to choose. Let's erase that and start over. Let's do like a nice green. Okay, so we have a negative slope and a negative slope. Yeah, it looks good. And then another negative slope from 3 to 5. Okay, so where does that happen? That happens here from, okay, negative 6 up to 0, we have a negative slope, and then 3 to 5. So that happens on negative 6 to 0 and 3 to 5. Remember, we do open intervals for concavity for sure. Okay, now the other part of this question asks for inflection points. Okay, so an inflection point is when f double prime changes sign. So f double prime, so that's saying that is when my slope of f prime changes sign. So where does this slope of f prime change sign? Well, it goes negative to positive there, and then positive to negative there. So I see those inflection points, those happen at x equals 0 and x equals 3. So again, go back to the definition of inflection points. When the second derivative changes sign. Okay, on our graph, that's the slope of f prime. So where does that change sign? And we see we have a negative slope and then a positive slope, and then a negative slope. So those are my 2 points right there. Okay, so that's how you want to do these problems. Again, write the definition right. What does concave down mean? What does an inflection point mean? And then think about where do you get that information from the graph or the equation or the table or whatever's given, and that should help you out. Okay, so that's this. This is an important problem. You'll see these on the AP test for sure. It might even be a whole free response question. So make sure you feel good about interpreting these f prime graphs, and we're going to practice this a lot. Before we meet again, could you guys please try this? So again, this is an f prime graph. And sometime you can do this on your notes or some other piece of paper. Go ahead and try and answer this question. Try and do the best you can. Go through and answer each of these questions just like we just did. And then we'll talk about our answers to that in class for the second one. Okay, good luck on that. Just try your best. I'm not grading on correctness or anything. I just want to see what you guys are doing, and we'll lead to a discussion in class. And bring me some questions, and I'll see you guys soon.